So SI quantities, graphs and motion. So this exercise is related to the physical quantities, the graphs are there, and the motion, explaining a motion. So first 10 questions already done. So I'll start with question 11. So in question 11, a car travels with a velocity of 50 plus 50 meter per second. While still traveling north, the car slowed down to 20 meter per second. Which of the following is a change in the velocity? So it has not changed the direction, it only changes the magnitude. So which one is representing the change in velocity? How to work out the, look, this is a starting velocity, this is a final. How to work out the change in a velocity? So change in velocity is always final minus initial. The final was plus 20 minus and the initial was plus 50. When we simplify 20 minus 50, so 20 minus 50 is equals to minus 30. So B will be the right answer. A student use a falling sphere to determine the acceleration of a free fall. So student is finding the acceleration due to gravity. The sphere is released from rest, so the initial velocity is 0. Which two quantities would require the fewest measurement to be taken in order to determine the G? Like we need the minimum values to measure the value of acceleration due to gravity. Look, there are 4 equations of the motion. What are the equation of motion? We have V is equals to U plus AT. S is equals to UT plus half AT square. 2AS equals V square minus U square, and S is equals to U plus V divided by 2 multiplied by T. These are the equations of the motion. So if we have a displacement and initial velocity, so displacement and initial velocity, we cannot direct, because look, in this formula we have the displacement and initial velocity, but two unknowns are there, acceleration and the final velocity, so we cannot use this. Here we have the initial velocity and displacement, but again two unknowns are there, the final velocity and time, and here acceleration is not involved. We want to calculate the acceleration of a free fall. In option B, displacement and time. So this one, time is there but no displacement. This one is having displacement and time. What about the U? U is already, because the sphere is released from rest, so we know U is 0. So U is also known, which is 0. So using this, like we can use a minimum, which two quantities require the fewest measurement to be taken. So we just need, if we have the displacement and time, we can use them to work out the acceleration directly. We cannot use why we cannot use this one? We need acceleration, but we have displacement, we have initial velocity, but we don't have the acceleration and the final velocity. Here also, according to, so it won't work. The final velocity and displacement. So again, if you check the final, there is a final velocity but no displacement. Here there's a displacement but no final velocity. Here we have displacement and final velocity. But to get the velocity, how you work out the velocity? Velocity is also displacement over time. Like you have to measure a displacement, or you have to use a light gauge or a camera to work out the final velocity. So directly, you can, the quantities which can be measured directly, and you get the answer, that is P. So fewest measurements to be taken in order to get the acceleration of a free fall. Is it clear, this one? In question 13, as you can see, this is a common graph is there in which a ball is bouncing. Which of the following correctly describe the motion of the ball? Look, usually what happens when we drop a ball, so what should be the shape of the graph? Because when we drop, its velocity is increasing. The moment it hits and rebound, it changes the direction and it changes the magnitude as well. Like the moment it hit, it will be zero and then it will rise up. So it will be maximum. And then again, as it is going up, it will decelerate. So slow down. But these lines should, and then when it reaches a maximum height, it will be zero. And then coming down again, it will velocity start to increase and this will continue. So the velocity time graph for a motion of a ball is shown here. As you can see here, there's a velocity time graph. So if the ball, if C and D are totally wrong, because if the ball was thrown upward, the velocity should decrease, not increase. But the velocity is increasing, so ball is going up, ball is being dropped. It's not going up, it is going down. And when it rebound, because it is when a ball hits the ground, it rebound and it rebound to a lower height. Why? Because you can see the moment, say the ball is falling. This is the point where it hits the ground. Its velocity becomes zero, and then it rises up. When it rises up, it has a maximum velocity to rise, but that velocity is smaller than the velocity at which it hits. So when this velocity is lower, it won't rise to the same height. It will rise to a shorter height because it will lose some of its energy. It will lose some of its energy, so it won't rise to the same height. So the ball is dropped and rebound to a lower position. If the ball is thrown, it will always be negative. No, if the ball is thrown upward or a ball is dropped, it's not like a negative velocity. It depends on what happened to a velocity, like which direction we are taking positive. So it is a relative direction. It's not like always negative. It depends on the same graph I can have for like this as well. It means I'm considering a downward motion as negative, so the upward motion will be positive. So it depends on, this is velocity is also increasing, but in negative direction, means the opposite direction. Which of the following graphs of a displacement against a time could represent the motion of a ball? So this is a displacement time graph. Like we have this is the same question, a similar question, which is representing a displacement time graph for this. So how you will know? There should be a graph here. As you can see, velocity, this is a velocity time graph. Okay. This part of a velocity time graph, this is a positive value and it is increasing. So we should have a displacement time graph, and the displacement time graph, the slope must be positive and it should increase. So from a displacement time graph, you can identify that whether you have to take a positive or negative. So now we have a velocity time graph. So we have a velocity time graph, and from this velocity time graph, we have to work out, because here what happened to a velocity, the value of a velocity is increasing and it is positive. So we have to check which graph it match with for a displacement time graph. So for a displacement time graph, So what should happen for a displacement time graph? Because this is related to the previous question, how we know it's positive or negative. If you see the graph there, so what happened to the velocity? This part, the velocity was increasing because the value of a velocity was increasing. So for a displacement graph, displacement time graph, what should happen? The first part, the slope should increase because the velocity is increasing. So slope should increase and it should be positive. The second part of a graph, this part is there, which is a very short interval. And then if I ignore this short change, what happened to this second part? The slope should be decreasing because the velocity is decreasing. Like here, the velocity value is -3, -2, -1. So -3, -2, -1. So velocity should decrease. So this is decreasing. So the slope should decrease. And what about the value of the slope? It should be negative because the velocity is negative. So value of the slope will be negative. So we will have a displacement time graph in which this first the slope should increase and then the slope should decrease. So which graph first the slope is increasing? So which graph the slope is increasing? So A, the slope is increasing. C, the slope is increasing. B and D are totally wrong because the slope is constant. And what about the second part? As the slope is increasing, the second part, the slope should decrease. And it should be negative. Here slope is decreasing. Here slope is decreasing, but it is positive because this is y1 and this one will be y2. So y2 is above y1. So here the slope is decreasing, but it is positive. But when we check this one, here the slope